Hello everyone, my friends, my viewers at home. How are you guys doing? Hope you guys are doing well. It's another exciting and a great day from the city of Benin, Edo State, Nigeria. And today, my name is Adrenaline, the Bazooka Prophet. And today we'll be working on a very interesting video talking about what we call the GLYOXYLATE cycle. Now, we should not forget that in our previous video, we talked about the Krebs cycle and the gluconeogenesis, and which will be very important in dealing with this aspect here because they are all related. Now, we should understand that the glycolytic cycle is an anabolic pathway in which glucose is synthesized from or is produced from fatty acids. Or we can also say that glycolytic cycle is a metabolic pathway in which acetyl CoA produced from beta oxidation of fatty acids are converted to a 4-carbon, talking about the succinate, and thereafter glycolate then to glucose, which is our major interest, even though amino acid too can also be yielded. Now, the glycolytic cycle occurs in the peroxisomes or the glycosome and also in the cytosol. Now, it is used mainly by species which are able to synthesize their carbohydrates from 2 carbon, talking about ethanol or acetate, and also in germinating seed, which must derive their carbohydrate from stored carbohydrates. Now, when we continue, we shouldn't forget that in gluconeogenesis, we said that it involved the biosynthesis of glucose from non-carbohydrate substances or molecules. Don't forget. And that example of these non-carbohydrate molecules include the pyruvate, lactate, Krebs cycle intermediates, and most carbon skeleton of amino acids. And at first, all these non-carbohydrates are converted to other acetate in animals, and thereafter the enzymatic processes occur to yield glucose. But that leucine and lysine, because they do not yield other acetate, rather they yield what acetyl CoA, they are unable to produce glucose in animals, but that in plants, plant is being able to convert glucose to convert acetyl CoA to glucose, and that they can do so via the pathway called this glyoxylate cycle. Take note, very, very easy. Now, let's continue. Now, we should understand that in the case of this glyoxylate cycle, there are 2 major enzymes that are unique or specific to the glyoxylate cycle, and they are the isofiltrate lyase and malate synthase, which you can see right here on the board. A, isofiltrate lyase. B, malate synthase. And some series of steps are followed. Number 1 is that the acetyl CoA is condensed with oxaloacetate. And remember, in our Krebs cycle, I told you the enzyme, and that the enzyme involved is called filtrate synthase. And that from this citrate to isocitrate, there is what we call an isomerization, in which citrate is isomerized to isocitrate by an enzyme called aconitase. Now take note, this is where you must pay solemn attention to what I'm about to tell you now. Now, in the case of this GLYOXYLATE cycle, because look at it, it is in this case, this step here, that is where the differences emerged, in which GLYOXYLATE cycle bypassed some of the steps in the citric acid cycle. How? In the Krebs cycle, the isocitrate is converted to alpha ketoglutarate by the enzyme isocitrate dehydrogenase. But in the case of the GLYOXYLATE cycle, this isocitrate is cleaved by the enzyme that makes this to happen, called the isocitrate lyase. Remember, it is unique. It is unique. It is specific for this GLYOXYLATE cycle. And when that happens, a 4-carbon substrate is produced called the succinate, which can now undergo a series of enzymatic reaction to carry out the Krebs cycle reaction. Whereas when succinate and GLYOXYLATE is formed, the enzyme being used to synthesize it, what then happens? The GLYOXYLATE is then also condensed with acetyl-CoA. Remember, with acetyl-CoA in the presence of the enzyme called malate synthase, which you have here on the board. And when that happens, from malate down to oxaloacetate, remember, if oxaloacetate is now being formed or produced, it means, remember that oxaloacetate is where is the road that will lead us to gluconeogenesis, in which glucose is produced. Now, these are what you need to understand, that in the case of GLYOXYLATE cycle, 2 carbon is being used to synthesize 4 carbon, which can be used to produce glucose. And that occurs what we want to call the GLYOXYLATE cycle. And please, if you know you've not subscribed to my YouTube channel, do well to subscribe. For now, God bless you. And remember, humble self, adrenaline, the bazooka prophet. I love you guys.